This is lesson 1.3, properties of real numbers. We're going to be talking about a few properties that are true for addition and multiplication, one of which is the commutative property. This is all about two things switching places, but it doesn't matter the order that you add or multiply two numbers. You'll get the same thing on either side. So if we do an example with addition, I could add 7 plus 6, but on the other side add 6 plus 7, and that equals 13 on both sides. Likewise, you can multiply and switch the order. So 5 times 2 is the same as 2 times 5. Both sides equal 10. And you could substitute in variables as well. So for this one, you could say b plus c is the same as c plus b. And for multiplication, let's go x times y is the same as y times x. So switching places doesn't really change what they're equal to. Associative is all about grouping, so look for these parentheses. That's a giveaway that it could be associative property. So think the group that you associate with, your friends, how you group them. So this is, say I had 3 numbers like 1, 2, and 3. I'm not going to switch the order on the other side, but watch what I do with the groups. So I could add 1 and 2 together and get 3, and after that add 3, which is 6. Or I could decide to add 2 and 3 in a group first, which is 5, and then add 1, and I still get 6. So keeping the same order, but just moving the parentheses around. And that works for multiplication as well. So if I have 7 times 1 times, let's go 2. And then maybe on this side, multiply the 7 and the 1 first, and then multiply by 2. So on the left, 1 times 2 is 2, multiplied by 7 is 14. On the right, 7 times 1 is 7, then multiplied by 2, you still get 14. So it's all about the parentheses. It's just regrouping. Additive identity, notice the word addition, so it has to be using addition. Think when you take a selfie with your phone, you get your same picture of yourself back. So I'm trying to figure out how I can get the same number back. What do I need to add to a number? So say I have the number 8. What do you need to add to 8 to get 8 back? That doesn't change it. Well, if you add 0 to any number, then it doesn't change it. So 0 is called the additive identity. Likewise, if you had a variable, b plus 0 is equal b, which is Bob, one of the minions, I think. Multiplicative identity, so multiplying. So how do you get the identity of a number back when you multiply? So say I had the number 7. How can I get 7 back if I multiply by some number? Well, if you multiply anything by a 1, you would get that number back. It wouldn't change it. Same with like c times a 1 is still going to give you a c. The additive inverse, again, it involves addition. You're adding two things of how you can get the identity of 0. So if you had a 12 here, what do you need to add to it to make 0? Well, you need to add its opposite, or negative 12. So this is about opposites. If you add a positive and negative of the same number, you get 0. Multiplicative inverse, it has multiplication in it. So how do you get the identity of a 1 using multiplication of two things? So if you had the number 5, if you multiply by its reciprocal, 1 over 5, then the 5's divide out and you're left with just 1. So really reference this chart when you are being asked to answer some of the questions in the Google form. It will be helpful for you to match up similar examples so that you can get those questions correct. All right, so why do we have these properties? Let's apply them. So Eric makes a list of items he needs to buy for a party and their cost. Find the total cost of these items. Use properties to help you. So we have these properties to make mental math easier. Of course, I could go right down the row and add the balloons, the decorations, the food, and the beverages in the order that it's on the chart. However, there's an easier way to group some of these numbers around that makes the mental math easier. So if you didn't have a calculator, so I'm gonna first switch the decorations and the food, and I'll tell you why in a second. So the reason I did that, so I swapped those two. So I used the commutative property there, is because I wanted to group the first two together and the last two together. Well, why did I do that? Well, 75 cents plus a quarter is a nice, easy whole dollar. So these two added together is just 30. And then 14 plus 20.50 is 34.50. So when I grouped it, I used the associative property. When these two numbers simplified and got replaced with something else, that is called the substitution property. So instead of writing two numbers and I turn it into one, I could substitute that number in. And then finally, our answer, our total would be $64.50. So that is also substitution. So make sure you write these properties on the side. So let's practice some problems. Raphael is buying furniture for his first apartment. He buys a couch for $300, lamps for $30.50, and a rug for $25.50, a table for $50. Find the total. So looking at these four numbers, think about which ones you would want to pair together. So I'm going to pair the 300 and the 50 together. So I'm going to say 300 plus 50. I'm going to group those. And then the other ones with the 50 cents, because I know 50 cents and another 50 cents makes $1, so that's easy to group. $300 plus 50, that's nice and quick, $350. And then if I add these two together, you're going to get 56. And then that just equals $406 total. So you should be able to do that without a calculator. These next two might take a little bit of thought. Evaluate each expression using the properties of numbers. Name the property used in each step. So think how you can apply those properties in the beginning of the video to make the mental math easier. So for this first one, I don't want to take 2.9 times 4 because I don't really know what that is. That takes a little bit of math for me. Yeah, I can do 4 times 10. That's a quick 40, but then I have to multiply by 2.9. So I don't like that decimal there. So what I'm going to do first is swap the order. So 2.9 times 10 times a 4. So when you switch the order, that is commutative. And then I want to group. I know that if I multiply 2.9 multiplied by 10, that's going to move the decimal one spot to the left, and it's going to turn into 29. So that's why I can do that. So when I grouped them together, that was associative. So I eliminated the decimal, and you can do 29 times 4. So a quick way to do this is to round the 29 up to 30 and think to yourself what 30 times 4 is, which is 120. And then if you take 4 away because you rounded 29 up 4 times, so I'll write this out so you can kind of see what I'm thinking here. 4 times 30 minus 1 is technically what you're doing. So this is 120. 4 times 30 minus 4 times 1, which is 120 minus 4, which is a 116. You could also break it up and say 20 times 4 is 80, 9 times 4 is 36, and then add 80 and 36 together. So those last few steps was the substitution property. So commutative switches order, associative puts parentheses around it, and then substitution to get the final answer. So let's look at the one with the fraction. 5/3 times 25 times 3 times 2. So I kind of want to get rid of that ugly fraction. And which one of the 3 numbers would be easy to get rid of the denominator of the 3? So I'm going to switch the middle. So that's times 3 and times 25 times 2. So when I did that, I was using commutative. Then we can group the 5/3 times the 3 together and the 25 times the 2 together. So that was associative. 5/3 times 3. You could put this 3 over 1. And then notice it would be 15 divided by 3, or these 3's can divide out. So this is just 5. And 25 times 2, that's 50. And so 250 would be our answer. So these last 2 steps was substitution. So sometimes the property names can be tough to write, but just make sure you're always thinking, did I switch order? Did I put parentheses around it? Did I just replace it with another number? So we're going to work with those more tomorrow. All right, and this last example, so we're going to do the evaluation of everything, but also justify it with the property that we can use. So think of the order of operations. First thing, parentheses. So I'm going to do the 4 minus 3 in the first line, which turns into a 1. I'm going to rewrite everything else that you didn't use. So if the 4 minus 3 just gets replaced with the 1, that means I made a substitution. It's like in basketball or football. When you're not doing your job, the coach sends a substitute player in your spot. Next, we want to do the multiplication. Because I don't see any exponents, so multiplication and division are next. 7 times 1 is going to turn into a 7. So think about that. 7 times 1 didn't change the identity of 7. So this was the multiplicative identity. Next, I see some multiplication at the end, so that's what I'm going to do. 5 times a 5th is equal to 1. So I can notice that 1/5 is the reciprocal. So this is going to be the multiplicative inverse. Then I could do adding and subtracting left to right. So 7 minus 1 is a 6. So when that just turned into a 6, that was substitution. And then we should know that 6 plus 1 is 7. So I could also substitute that number in. All right, so make sure you answer all the questions in the Google form, hit submit, and we'll talk about this stuff in class the next day.